Good evening. Welcome to my weekly live stream. Sorry for the delay getting started this evening. Kids' bedtime overrunning slightly, but here we are. This is my weekly live stream doing some Node-RED development work, an hour and a bit or so. Have we got sound coming through? Let me know. Can you hear me all? Because in the chat you're saying you can't. Yes, you can hear. Awesome. Yeah. So hour and a half or so, well, hour and a quarter. Got some interesting development work to do this evening on a 2.1 feature. Question in the chat, does anyone know who created the starting animation? It's really cool. Well, that would be me. I created that. No, there's a, yeah, that was me. And I'm very glad I did do that placeholder. So when I am running a bit late, I can at least hit start streaming at 8 o'clock. So you all know I am here, and just leave that placeholder there so that you know I am going to arrive imminently, which is always good. So what are we up to this week? We are doing some stuff with the link nodes. So let's go and have a look at what we're talking about. Let me just clear some space and show you my screen. Here we are. So yeah, we're going to do some stuff with the link nodes. So the link nodes are slightly special nodes we have in the palette that allow you to create virtual links between flows. So you've got the link in and the link out. So here I'm going to just create a little flow. Oh dear, that's not so good. What's crashed that then? I don't know. Right, we're going to have to rebuild that. That's all right. Thankfully I hadn't done lots. Yeah, so we've got link node, an input, well, a function node in between a link in and a link out. And we're going to name our link in, what are we going to call it? Just trying to think of what this worked example is going to do. I'm going to call this one multiply by 2, I think. That's what we're going to do it. Oh, there's an error down here. What's going on? Interesting. Errors. Yeah, I should use the align shortcuts. You are quite right, but that's curious. Okay, I'm not going to get distracted. There were errors, but so we've called this link node multiply by 2. So we're going to say message.payload is message.payload times 2. Return it, and then the link out node. So then what we can do is have another flow anywhere else in our workspace with a link out. So you can see there's no visible link between these two, but what I can do is drag this dotted wire between those two, and it adds what we call a virtual link. So normally when nothing's selected, you don't see those wires, but as soon as you select one of those link nodes, it shows that virtual link. And that works across between different tabs. So if I were to copy those two and paste them over here, when I hover that, you can see it shows it's connected to something on this flow, and I click on that and it shows, and now it shows this input is linked both to something on flow 5 and linked down to this one. So what we're going to do is set payload to a number. Let's say it's number 2. So that's going to inject the message, pass it over the link nodes through our multiply by 2 function, and then we're going to have a link in and debug. And yeah, let's just do it this way. So I called that multiply by 2, and we're going to call this one multiply by 2 result. So then this node we are going to connect to. That is interesting. Yeah, I need to check what something breaking there. I'm not sure. Anyway, so now hopefully you can see exactly what this is going to do. When I inject, I get a payload of 4 because it's passed through, and that's nice. Link nodes are sort of an alternative to subflows, where if I had a common bit of flow that I want to be able to call from lots of places, I could set it up as a link node. Wrap the common flow with link nodes so I can call it. However, and this is essentially the problem with trying to use link nodes to create like subroutines, and it's this. Let's say I wanted to reuse this multiple by 2 in lots of different places in all my flows. So, at the moment I've got a nice instance here where I send the result and I get an answer. And in fact, delete that. Duplicate that group. And now this time I'm going to inject a 3 just to be different. Now when I inject this, I get the answer twice. And I get the answer twice because this output is wired to both these debug nodes. And that's the problem with link nodes if you want to use them to create like subroutines, is that the link out will pass to everything it's wired to. There's no concept of just passing back to whatever whatever triggered the flow in the first place. What we want is some way of having a node sit in this flow that calls this link node, and when the result gets to this output, it comes back to the node that invoked it, rather than back to everything else it's wired to. So that's what we've had in the backlog for quite some time. And there are a number of third-party sets of nodes that that provide that sort of behavior, even though it's been in our backlog for ages, and it's never translated to anyone contributing to help add it to the core, such as open source. So yeah, I thought actually, at the weekend on the back of the most recent conversation around that sort of functionality, I put together a design note on what this would look like. And I thought, this would make actually quite a nice self-contained thing to try and do on tonight's live stream. And here we are. So the design has 2 parts. 2 main parts to the design. Part 1 is a new node, which, for want of a better term, we are calling it the link cool node. So this is going to be a new node we'll add into the palette, and it will sit alongside the 2 link nodes we have at the moment, called the link cool node. So what that will look like, it won't look like a function node, but it will be a node that sits in the middle of a flow. So let's create a third copy. I want to keep the other 2 for testing. So it's effectively going to look like this, where this will be our new link cool node. I'm still getting these errors. Is this? I know what this is. This is in development code in my workspace. Anyway, don't worry about those errors. I will try not to let them distract me. So we're going to create this new node that can sit in the middle of a flow like this, uninterrupted. And when you configure this node, you will be able to point it at a link in node. And so when this receives a message, it basically acts like a link out node, in that it will pass a message to whichever link in node it is configured to talk to. And it will do some magic with some message properties, which we'll get to when we get to. The other part of this then is a new mode of operation for the link out node. So at the moment, the link out node, as I've demonstrated, will send a message to everything it's wired to. What this design proposal, and I will say it's a proposal, part of the reason for working on this tonight is to implement it, see does this feel right. Yeah, so the fact this is blank is troubling me. This feels like there's a bug here, which, okay, we're going to have to address because we need this working for what we're looking at. But the point is, for the link out node, the second part of this design is to a new mode of operation. So in the edit dialog, there'll be probably a select box or something to pick its behavior, which is send to all connected nodes, or return to cooling node, or return to, again, we're going to have to figure out the right way to describe it. But if it's in return mode, then when it receives a message, it will pass the message back to the link cool node that triggered the message to get to it. And the way that will work is the link cool node, well, there's going to be this new property the link nodes will set on the message called link source, which will identify where this message has come from, so that when it reaches the link return, or the link out node in return mode, it will use that message property to work out where it needs to go back, and it will then send the message back to this node's internals, so it can then send it on. Okay, so that's the plan here. I'm certainly confused by this being a blank. This should be a list of all the link nodes. Something has gone awry, so okay, hopefully this doesn't bog us down, but this is, we're just going to crack on, because we want to work out what's going on with that link node edit dialog. So here we're in link.js, which implements, we don't want the .js, we want the .html, because at the moment we're doing everything in the runtime side. They're pretty simple nodes, but yeah, for the life of me, let's just collapse things down so we can see things a bit better. Is that going to collapse things down? No, that's not working either. Okay, so here's the link in node. So on edit prepare, this is where I think things are going awry. So it's building a tree list, the UI tree list. It's then doing candidate nodes, and it's doing a filter for the, so it's basically getting a list of all of the target types of nodes that it could wire to. So for the link in, it will get a list of all the link outs, and vice versa. So curiously, can state nodes. Whereas my atom screen's misaligned, so you can't see everything I can see. Let's just shuffle everything around a bit. Why not just allow link in, link out nodes to have multiple inputs and outputs, which is similar to other things in. The multiple inputs, multiple outputs won't cut it, because you need to, let's say I wanted to use this in 100 different places, then it's just not practical to have 100 different wire. The whole point of link nodes is to try and simplify the wiring. So multiple output, because you also need a way to identify which output should it be sent to, and how do you route it to where it needs to be sent to. So unless I've misunderstood something about your suggestion, I don't think it really solves the problem. But let's figure out what's going on. So candidate nodes is meant to be a list of all the nodes that it can be wired to. So when I edit this, I'm getting an empty list. That's not good. Okay, so red.nodes.filterNodes is broken. I know I've made some changes in that area recently, but so let's just try. If I search for type inject, I get nothing. If I do type link in, I get nothing. Okay. Well, that is a downer. We need to go fix that. So here we have the filter nodes function. So it's designed to filter on two different things. One on the Z property, so Z being which tab it's on, and the other is the type. So, there are some optimizations in here so that if you are filtering on Z, it can instantly, because we maintain a mapping of tab to node, sorry, let me do. So we're passing in a filter that doesn't have a Z property, which means the search set should be the full list of nodes. Ooh. But I don't think nodes exist. I think I've made some changes and nodes doesn't exist anymore. Right. Oh, yeah. Okay. Oh no, but here we are. Sorry, I'm just talking to myself a bit. Now this is good. So basically, it starts by working out can it reduce the set of things it has to search, and if not, it then reverts back to searching the entire list of all nodes. But nodes is no longer an array in this. Yeah, I made some changes to the internal representation and I blatantly just missed this. Okay, one sec, let me... Yeah. Oh, this isn't so good. Okay. So tab map is an array. If we're really having to search everything. So nodes used to be an array, so I used to be able to just iterate through it. Nodes is no longer an array. Nodes is now an object of IDs to node. So, okay, I'm just going to do a quick hacky fix here. Don't dwell too much on what I'm writing here, guys. This is just to unblock everything I need to be doing, what I plan to be doing this evening. Object lookup. Node is nodes, node, yeah. Oh, hacky, but that should do it. So if I now, oh, that's better. Doesn't that look better? So, okay. Crisis averted. So, Right, back on track. Let's look at what we've got. So we've got the link call node and this new return mode for the link out node. Let's start by adding the link call node in. Okay, that's where we're going to start. So to do it, we're going to add it to the same node files. We're not adding new node files, and there's a reason for that. We'll get to that in a minute. And we are, I'm just going to make life easy. We're just going to copy and paste the link out node and just do a bit of renaming. Link cool, link cool, cool. And for now, we'll just no op it. So just whenever it receives a message, it just sends it straight on. In the runtime side, we're going to be doing this incrementally. From a UI perspective, we want, I'm going to pinch the link out node, call it the link cool node. It's going to have a name field, because everything does. And then it's going to have, we're going to steal the node filter. That's all good. Yeah, no, we'll stick with this for the moment. It's not quite the right UI, but we'll stick with it for the moment. And then we want to register the type. So again, I'm just cribbing the link out node, call it link cool. We don't yet have an icon for it, so I'm just going to reuse the link out one for now. It's going to have both one input and one output. It connects to link in nodes, so that all stays for now. We don't have, we'll have to add proper NLS names for it. And then on edit prepare, so this is the utility function for the link nodes that builds that list of nodes to select. We want this one to call, to be virtually wired to link in nodes. So that's right, and that's right. And then, yeah, what does on add do? Yeah, no, we don't need the on add for this one because our wiring is one way. Okay. So now when we reload, we now have our link cool node. So what I'm going to do is edit this, get rid of that function, and drop in our link cool node. Deploy, and when I pass a message through it, it passes straight through, which is exactly what we expect because that's what the runtime side does. But we're not worrying about the runtime side yet. So here we can open up the edit dialog, and we already have, okay, we can pick what it calls. So we want it to call multiply by 2. And if we just go to the info tab and check its edit, so you can see its links property is set correctly. Now, this is where it needs to start to deviate from all that code we've just copied. The link in and link out nodes allow for many-to-many type wiring. So this link out could be connected to lots of different other nodes, just like any other nodes. The link cool node, semantically, it gets difficult, I think, if you allow it to be connected to multiple things, because there we're saying send a message to these 3 different places, but if they all return a message, what do we do? Are we meant to join them together somehow, or are we meant to block indefinitely until we get all 3 responses back. They're all... I'm sure there are scenarios where any of those patterns would actually be quite desirable. However, for at least the first version of this node, I don't want to over-engineer it. There's enough to be doing. So what we want to do, rather than allow you to pick multiple, is we just want to let you pick one. So that's going to need a bit of UI work to make this, rather than checkboxes, to make it like radio boxes. I'm not going to do that on tonight's stream, but that's something on the to-do list before this can get merged. So for now, we're just going to connect it to 1. Okay. Then I'm going to leave the property as an array, even though we're only going to wire it to 1. Under the covers, we'll keep it as an array, just because in the future we decide, actually, here's semantically a sensible model where it could call multiple things and gather the results, then being able to identify multiple, may as well have it as an array to begin with. So, so then we have that. Then, what are you saying in the chat? So Steve, for short-term, check length of selected links and error if greater than 1. Yes, I could spend time writing that validation in now, but to be honest with you, I think I will solve the UI thing before this stuff gets anywhere near a merged pull request. So I'm okay with it being sticking on the happy path. But yeah, that there's absolutely some sensible validation could be applied that does the right thing. Maybe multiple selection, create 1 output link for each. Yes, although that's a possible model. I think it then gets... One of the concerns is we don't like magic messages jumping around the place. So one of the reasons this node has kind of sat in the backlog for the time it has is we didn't have a clean and clear way to visualize. Like with the link nodes, when you select it, it reveals their wiring. We don't have any way of doing that with the link call node. We have no mechanism, or no nice mechanism of having any virtual wires come out of a node to show where it's connected and where the return comes from. I'm sure we could invent some. Well, that's the point. We haven't come up with a nice visual appearance. You are at the right moment. This is the link call node. But in many ways, this is just like subflows. And again, that's one of the other reasons we haven't rushed to implement this, is there's nothing to say, that couldn't be a subflow sat in between. But there are instances where people want... The downside of the subflow approach is if you want to have lots of these little subroutines you can call from lots of different places, you've got to have a unique subflow for each one. And then if you're wanting to make edits across different subflows, then they each end up in a different tab. Whereas this approach, you could create a single tab in the editor, which is called my subroutines, and then you just define all your different subroutines in one place. So it's a different way of organizing it. Another reason being each instance of the subflow is a genuinely unique instance. So it is a copy of all the nodes running for each instance you have. Whereas this approach allows you to have effectively a singleton. So if this node was maintaining any state, then that state would be the same for all users. So yeah, that's yeah. And that's it. Yeah, you want single instances. Now, to be fair, we have had on the design backlog a singleton subflow as a concept, which again is this idea of being able to tick a box and say, make this subflow a singleton. So don't create a copy of it for every instance. Just create one instance of it and deal with all this routing of messages for you. So that's another route of going. But anyway, for now, we're exploring the link call node. So we've got a node. We're identified. We've wired it up. So what do we do next? Well, we go into the runtime side and we're going to say target is n.links 0. Again, we're not going to spend a lot of time putting error checking in this right now. I'm just going to sort of crack on. So target is going to be the ID of the node that this link call node is targeting. Then we are going to, what are we going to do? We're going to do red.nodes.getNode target. And then do target node.receive message. And then, well, we can't call done because at this point we've only done half the job. But let's see what this does. So we've got the link call node is targeting multiplied by 2. We're going to inject, again, let's just give it a unique number just to help matters. So now when I inject this 4, we get 2 8s, which is good. So if you weren't here at the start, so what's going on? So we've passed the 4 to this node. It has successfully passed it up to this guy here. And you can already see interesting artifact. The editor has detected that this node has a virtual link to this one and it is drawing that virtual link in place. We're going to undo that because it's visually incorrect to say the output of this node goes up here, because this dotted wire should be coming sort of out. That dotted wire comes out of the middle of this node. But anyway, we have successfully sent a message from this node up to the targeted link node, and it's gone through, and the result has been passed to everything that this link out node is wired to, which is these two. So we get 2 8s. What's up, Bob? For the to-do list with lint following links, could this be caught as a loop? Well, yeah. So we have loop detection rules in the linter. You're right. On the to-do list is then thinking, okay, what new lint rules can we introduce? Because there are going to be some new rules about how these nodes get paired up, which the linter can help police. So that's the very first part of it. Now, if we switch back to the design note, we've got this bit to implement next, which is saying before passing the message on, it sets this message.link source, and that name may change, but we're going to stick with it for now. We're going to make sure it's an array, and we're going to append to that array the link call node's ID. So let's do that, and I'll explain why we're making this an array in a sec. What do we call it? Link source. Yeah, link source, link origin. Don't know. So we're going to initialize it to an empty array if the property doesn't exist. Then we are going to push node.id. So why make it an array? We're making it an array because we want to support nested link call nodes. So if you think of it, we have a link call node here that's wired up here. Now let's say I had added another link call node in here, which called yet another subroutine I have somewhere else. We want this to act recursively. So when a message arrives here and it calls off to its other subroutine, we want it to come back here. And then when it comes to this point, we want it to return back to the original link call node. So if we were just using a single message property, if we were just using a single message property, then we wouldn't be able to do that keep track of the call stack. Now, that may change because there's another bit of this problem to solve, but for now, this is first iteration. So that's all we have to do. We make sure link source exists as an array, and we push the node ID. Right. So let's now turn our attention to the link out node. What we're going to do with the link out node to begin with, the design says we want to add this new mode, return mode. I'm not going to jump straight to adding that UI. What we're going to do first is let's just assume all link out nodes are now in return mode for the sake of what we're doing here. And believe me, this is going to get a bit hairy in a minute for other reasons. But when a message arrives at a link out node, we're going to say if link source exists and link source dot length is greater than 0, then we want it to be a valid. Anyway, I'm just going to focus on this for a moment. So turn target is link source dot pop. So take the last one off the array. We want to go and get that node. There's more type safetyness we should be adding, but this will do for the moment. Okay, let's do array dot is array. For the sake of that works because that handles null and undefined for us. Okay, so we get the return target, and then assume, again, put a bit of safety around this. Do the same down here, target node. Okay, so now we've got a challenge. The message arrived at the link out node. We've identified it's come from a call node, so we want to return it. How do we return it? Down here you saw how we passed, you may have seen, down here you saw how we got hold of the node and then we just called its receive function to receive the message. Why don't we do the same just here? Call return node.receive. Well, the problem is that will invoke this message handler, which will then send the message to the target of its call. So on the wiring diagram, it would mean a message will come in here, it'll pass out, it'll go through, it'll come back down, and it'll come back in the input and then it'll get sent out again, and it'll just get stuck in a deadly loop. So we don't want to do that. What we want to do is to be able to return a message into the heart of this call node. And that's why we're introducing the link call node in the same file as the other link nodes, because we're going to do a little bit of magic. Well, yeah, it doesn't need to be in the same file, but we're going to be doing some magic. What we're going to do is let me get this run the right way. We are going to say link call node dot prototype dot return message. Let's see if this works. So we're adding a function, a custom function to the prototype of the link call node, return link message. And then what this is going to do is do a this.send message. In fact, we're going to do one more thing here. We're going to say if array.is array link source and message.link source.length is 0. We're actually going to tidy up after ourselves and delete. If there's nothing left in the stack, we're going to delete it. Okay, so having done that, we now know our return node should be an instance of the link call node. And just to make sure, we are going to, let's check that object, that node has that function. And we're going to do that. And then return, because we don't want to do anything else. And we're going to do away with that. Yeah, I've just commented that out because we will need to reinstate that when we move out of link mode. Okay, so let's see what happens when I inject. I only get one debug message. Now when I highlight it, which debug node is going to show it? Yes, it's the debug node in our link call flow. So the link call node is working. Let's we'll call that ×2. Just gonna clear all them off. Just getting rid of these, just make life a bit clearer. And I'm going to call this one a multiple by 3, let's say. Okay. Then I'm going to create, I'm going to get fancy. I'm going to create a test flow which first does multiply by 2. Oh, I need to rename this one. We're going to call this one multiply by 6, because what do you get when you multiply by 2 and then you multiply by 3? You get multiplied by 6. That makes sense, doesn't it? So then this link node we're going to target multiply by 6. Is this going to work, or is this just too crazy? So 4 times 6, need to change the ×3 function. Did I not change? Oh, thank you. Good spot, that man. I was going to be horribly disappointed. Right. So 4 times 6 is 24. It worked. Yeah. So That's good. That's done. Yeah, that's done recursion. It's done nested calls. This guy called multiply by 6, which is this one. Nice. Yeah. Okay. So that's the basic functionality of link return and link call working. Add link call to the other two groups. Ensure individual returns. Good suggestion. So, oops. So let's add a link call in here. Link call in here. Oops. And we'll multiply this one by 3. Let's do them both by 3. So if I inject 2 times 3 is 6, and I only get the one response. And 3 times 3 is 9, which is the right answer. And 4 times 6, 24. Cool. That is all working nicely. So what next? Well, there's plenty to do. First up, I'm going to make life a little easier, these link call nodes, I'm going to change their label. So at the moment, their label returns, here it is. In fact, that's right. So their label returns either its name property or this message catalog string that we haven't come to terms with. So what we can do is say, slightly change this. If this.name, return this.name. So that still takes precedence. If links, this.links, let's get the target node. Target node is red.nodes.node this.links 0. Then we'll return target node dot name, otherwise target node dot ID. Yeah, that's probably right. Otherwise, we'll fall back to its default label. Then we will set the title to be italic if this.name is defined or this.links.length is greater than 0. We'll just assume basically it's been wired to something. So what does that look like? So now you can see the link call nodes have got the name of what it's going to invoke, which is nice. Right. So that's the easy path, but we've got a bunch of other things to take care of. First up, possibly, hold on, some questions. What happens if there are two link out nodes connected to ×2 or ×3? Well, if at the moment, let's say I add 2 output nodes like that, and then I invoke it here, I get 2 answers because it is returned twice, which is true. The message has been returned twice because it's come through 2 places. That could cause some hairiness for other reasons that we'll need to get to. But one thing at a time. And the thing I want to look at next, I think, is this link out node. I want to be able to put it in, be able to say this is a return node rather than just because right now, if I were to wire this up, let's just get a regular link in debug, and if I connect those two up, why has nothing come through? Oh yeah, okay. That's not working, but that's because I have intentionally, temporarily broken the link nodes by disabling this send. What we want to be able to do is to be able to put the link out node into return mode explicitly. And if it's in return mode, it will only do anything if the link source property is there. If link source is not present, then it'll probably log an error, because just like the HTTP response node will log an error if you pass it a message that hasn't come from an HTTP input node, I think it's kind of the same deal. If a message reaches a link out node that's in return mode, and that message hasn't come from a link in, or hasn't been triggered by a call node, then that's a programming error. That will be an invalid configuration. Something the linter would potentially be able to help detect configurations that do that. Can label be selected link type? Yeah, I think that's what we've done. So how are we going to do this? So we want to go and edit the UI of the link out node, and we want to, how are we going to do this? We're going to have a mode whose default value is going to be link, because by default it is links, but we're going to say that can either be link for the old behavior, the normal link node behavior, or return for the new behavior we're adding. So if we just go into the runtime, we can add the logic around that now. So here's the link out node. Say mode is n.mode, and we will default that to link, because if this property isn't set, then it's an existing node, so its default behavior must be link. Then, yeah, this events.emit stuff, I think this is the original implementation of the link nodes, and it's been left in place, which is entirely questionable about whether that should be there or not. But again, I'm not going down that rabbit hole right now. But what we'll do here is say if mode is return, then this is what we do. Else if mode is link, then we do what we did before. But crucially, we can get rid of that return now because we've got the if statements to deal with it. Yeah, and we'll stick a done there, because once we've got to that point, we're complete with the message. Here is node.warn. No, I'll go check the HTTP response node to see what the message is if you pass a message that hasn't come from an input node. No cool return target. Yeah, that's an awful message. Users won't know what at all that means, but again, for our testing right now, that's good enough. Yeah, we'll deal with that there as well. Cool return target, not link cool node. Now, that's an error condition you wouldn't expect anyone to hit unless they were manually handcrafting their flow and they got their flow wrong. All right, so now we've got the runtime behavior. So let's just check that. What was going on there? No, we're all good. So now, yeah, let's just inject these. We get the 6, which is goodness. Oh, that's interesting. That is interesting. What's gone wrong here? So I'm injecting the 4, but I'm not getting anything out. And that's because all of these nodes are in... yes, right. So I injected the 2 and I got 6 and I said that's right. But when I hover it and I see which debug node got the 6, it's this one up here. It hasn't returned. And that's because these nodes don't have this new mode property, which means they're fallen back to link mode. So they're doing the right thing. They are pre-existing output nodes and they've fallen back to link mode, and they are, as far as they're concerned, wired to this guy. Well, the ×3 node, I should say, is wired to this guy. So it's doing the right thing. It's not doing what we want, but it's doing logically the right thing. Okay. So we want to now give ourselves an option in the link out edit dialog as to what mode of operation it should do. All right, let's just... Now this wants to be a select box, I think. Node input mode. Option value equals link. Send to all connected. I generally prefer, so yeah, select box or a checkbox is always an interesting question in a UI design point of view. My take is a checkbox is good if it's a binary thing, in that it's something is either on or off. When it's choosing between two different behaviors, two different modes of operation, it's hard to... You only have one bit of text, which you're either agreeing to or not agreeing to. So that's fine to know what you're agreeing to, but it doesn't tell you the counterfactual. It doesn't tell you what it means if you don't select it. So I do generally prefer to have select boxes, because then the labels are explicit as to what option, what behavior have you chosen. That's my take on it, at least. Yeah, and as Steve says in the chat, it provides space for a third option. Send to all connected link nodes, and we want option value return. Is that what I call it? Send return to calling link cool node. Yeah, definitely have to sleep on choosing are these good names or not. Right, let's reload and see what that looks like. So it's the link out node. Cool, we've got the mode. Just check that's all resizing properly. Yeah. Send to all connected link nodes and return. That's all working. Just need to fix the width. We really need to... Node-RED 3.0, if not before. Going to have a bit of an overhaul, I think, of our default CSS for some of this stuff. Just it's evolved slightly scrappily. Sorry, I don't want that to be class. We want this to be style width 70%, which, yeah, let's make things worse before they get better. So at least now it's consistent with the box above, which was good enough for now. So send to all connected link nodes, return to calling link node. Yeah, okay. That'll do for now, but we need to do a bit more work to set that up. So link call node, link out node on edit prepare. So we, after we've called the utility that sets up the tree view, what we're going to say is first up we need to cope with if mode doesn't exist, do we? In fact, we cheat. We can, if I set selected on that, that will set the default value. We want to do add a listener. Ooh, sorry, wrong button. There we are. Node input mode on change. Then, is that right? I have to say, I never get this right first time. So if we change that, yeah, you can see we're getting the right value. So this dot value is the right thing. Then what we want to do is hide the list of nodes, which is this row, which we're going to give it a quick ID. This is the node input links row. I think that's okay. I think that's no. Sorry. Node input. Oh. Dislike this naming. So I'm going to give them both a CSS class. And yeah, my pause was... anyway, I'm giving this class name. And we're doing that because what we want to do whenever we change this value, we're going to tell we want it to be we want to show it when the value equals link. Is that right? Have I got that? Can't remember which way around that option goes. So return to calling link. Okay, it's showing it. If I do send to all, well, it's still showing it. Well, that's not worked at all then. Let's just check that does. Okay, that's not working because there's nothing with that class name. What have I done wrong? Oh, because I've added it to entirely the wrong link node. This is the link out node up here. So let's just move back move up what we had. Good. Let's try again. Cool. So when return to calling link node, it doesn't show anything. When send to all connected link nodes, it shows it. Okay. Gradually getting there. Now, it is also true to say it's not working as I thought. That is blank. So we need to do a little bit of work here. If this dot mode, well, say if not this dot mode, then we're going to have to do the legwork ourselves. Explicitly set that to link, and then trigger change. Cool. Okay, we are getting. I've been ignoring these errors because I was getting errors before, but these are actually new errors. So I'll. Yeah, okay. That's due to the link node stuff we've added. All right, but this is now working. So return to calling link node. Let me check its properties. You can see the mode is now return. Whereas if I say send to all connected link nodes, the mode goes to link. Okay, tick, next. So that's fixed. So we're now able to put the link out node in return mode, and we've done the logic in the runtime to do the right thing. What next? What next is I quickly want to fix these errors. So these errors are coming about when it's trying to generate the label for a node. And the reason these errors are happening is it's trying to generate the label and there's a point in the life cycle when it's trying to generate the label when this node has been added, but the node it's connected to has not yet been imported, which means which basically means target node doesn't exist. And so this line is what's blowing up because we're trying to reference a property of undefined. So so we just wrap that up like that. Yeah. So refresh. Shouldn't see any errors down here. Nope, no errors. Okay, that's fixed, which is goodness. Let's just go have a look for this guy in the sidebar. Yeah, multiply by 3, so that's good. Right. So we're gradually getting there. A few more things to deal with, I think. A few more things to deal with. Right. This guy. No, but let's do this times 3. So this is where we have this problem of it's drawing the virtual wires to these call nodes, but because the wires are coming out at the end of the node, it just looks wrong. Because again, as I said, semantically that's meant to be the output of the node. It's not in the right place. And it's automatically adding in those wires because why is it doing that? So basically there's a bunch of code in the editor that looks for these sort of inferred connections whenever you select an input. link in or out node. It looks for things it's connected to. So for the moment, we want to make sure we filter out if the destination is a link call node and not one of those other link nodes. So it's already 9:15. So hold on to your hats, because we're delving into the 5,500 lines of Vue.js. And I need to very quickly think about how do I find the bit of code show drag lines. Hide drag lines. Ghost node, drag lines. Update selection. So this, okay, so we're in update selection. This gets called whenever you change what's selected. Yeah, Steve, there's, to be honest, at the moment I'm just trying to remove the noise to then look at what makes sense to display, and it's quite distracting having these virtual wires pop in and out of existence all the time. So yeah, this is the code that's whenever you change your selection, it loops through what is selected, and if it's a link out or a link in node and we're in the active workspace, it goes and has a look for everything it's connected to based on its links property. So that's interesting. If we go back in here, and here's a node, and if I export it, look at its JSON, you can see its links property does have actually those nodes listed. But when I open it up, oh, okay, of course they don't get shown there because this only shows me the link. It doesn't list link call nodes. Yeah, so here's an example, I think, of what you're saying, Steve. Here I've got a link in node which is connected to a link out on a different tab, as well as to this guy. To us, yes, there's things we could do up here. It's more, what I don't have an answer to is what we do down at the call node to indicate what it's calling. That's what we're missing at the moment. Yeah, for now, I just need to try and just trying to, so those links are getting drawn because this link in's properties list the call nodes. I think, yeah, and this is one of the unique things with the link nodes is their links properties are bidirectional. So if I have a regular, if I have, try again, link in, link out, I have a couple of each of these. So you can see in its properties over in the bottom right corner here, its links are empty because I've not added any. And this one down here, its links are empty. If I wire those two together, you can see how this node links now has one in, and this one's links now has the opposite one in. And if I delete, those two properties should go back to being empty. But also, if I edit this node and I select, I think it was, yeah, DB4E. now you can see it's got db4e has its links property, as has that one. And I think that's what's happening up here, because I'm reusing this UI, the list of nodes UIs. It's calling this onEditSave function, which is shared by all the link nodes, which is here. So this goes through the tree list. It finds, basically builds up a list of everything it's connected to. But what it then does, it then does a bunch of stuff. It does, it does a bunch of complicated iterating over lists and splicing and yada yada yada. And it does that because what it's doing is it's going to everything it's connected to and updating that other node's links object. So by configuring it on one side, this is the code that does the work. Well, this is all the code that it takes to update that property on all of those other nodes as well. What I think makes sense and I'm going to have to remind myself why old links exists. Is there going to be some magic here to do with being able to undo these edits? I suspect there's some magic in this. You know what, I'm just going to go have a quick look. Okay, no, maybe not the magic. Not necessarily the magic I thought. Anyway, point is, I think what we can do at this point is say if node.type is a link call node, then we can return early and not update the remote end. But to test that's worked, we've got to tidy these nodes up a bit. So I've just deleted those two, and I'm just going to add them back in. I'm going to call this one M2. This one M3. So what did we have? We had, so this link call node, we want to connect to M2. This one will connect to M3. That one is still connected to multiply by 6. This guy we were going to multiply by 2. This guy is multiplied by 3. So having done all that, let's just check their links properties. So that's got a single entry. Yep, that's all doing. This one is empty and this one is empty. Good. So the code has worked. It's not modified up there. So does that still behave as we expect though? No. So 3 worked. Why did 3 work? So M3 because these aren't, let's put these back into return to calling link mode. So here's another bug we're going to have to address. So putting return to calling, when it's in that mode, it needs to wipe out its link array because we don't want this node in return mode to be wired up to anything. But for now, if I inject 2, I get 4 and it's on the right debug node. If you can see that, you can see it's highlighted the debug node on that row. Inject 3, we get the 9, again on the right row. Inject that. Oh, and we haven't. But that's because this one is not in return to calling link mode. So that's all worked. Now, there's... Yeah, okay, let's just tidy that up. By putting this, if a node is in return mode, then it shouldn't have any wires, so we need to make sure we clear those wires. So we're going to say on edit save of the link cool node. On edit save. Then we want to in fact, we're going to put some logic up here in on edits. Yeah, in on edit save. Then if node.type is not equal to link out, or node.mode equals link. So what we're saying here is only go and check that tree list for what's been ticked if it's not a link out node, or it is a link out node and the link out node's mode is set to link. However, we can't rely on node.mode being updated yet. So we need to check the select box, check its value. So pull out of the tree list what has been selected if it's not a link out node, or implicitly it is a link out node and the input mode is set to link. Yeah, that's... I could do it as not equal to return. It's the same. Prefer to try and keep it affirmative. So if I edit this and hit done, yeah, I need to get rid of this unrelated code because I keep seeing these errors down here and they're not related. So here you can now see there are no wires, and this guy, he's not wired, so it's effectively severed that link. Yeah. Now, it could be if we realised you've put it in this mode, and let's just, if I have some ticked in that list and I put it into return to calling link mode, then we could also add up a warning saying this will remove all links, existing links, are you sure? Maybe. I mean, it has to just be a prompt. It can't be a confirmation dialogue. We don't do confirmation, are you sure type things, but it at least could be a notice that this is going to sever those links if you deploy that. Okay, we're gradually getting there. Where's that come from? Oh, but I didn't recreate this one, did I? I only recreated these two, so yeah. Okay, just let's tidy everything up. Okay, I think I could keep going for hours on this because I'm in a groove, but that would not be a welcome move by people downstairs if I stay here for much longer. So we've got the basic bare bones of it working, which is awesome. We've got the link call node. We've got the return mode for the link out node. We've shown we can nest them and sort of do cool stacks going almost, not recursive is the wrong word. We can nest calls. But there's still a bunch of usability stuff to worry about. So there's better validation of properties. There's things like, we need to not show this output port for a return node because we don't want you wiring it up. It's meant to be in return mode. It's also true to say one of the open questions on the design is it right to overload this link out node to have this dual mode? Would it be better to have an explicit return node, a link return? That is a valid question. I've started out by trying to overload the link out node just from a let's see, does this feel right? Does this make sense? Point of view. Still feels probably an okay way to take it. What's this? 9. Oh, well, that's something I'm just going to copy your message and I'll stick it in Steve. Thanks for that. I'm just going to make a note of that, and I'm not going to dig into that right now. But if you think there's something there, then please do throw a pull request in. So I think there's some usability stuff. I want to get rid of. I don't want it displaying this virtual port if it's a return node. There is a visualization question of better visualization of what this link cool node is wired to. Is there a better visualization? Just to glance at them, you wouldn't know that these are return nodes unless you selected it and saw it didn't have the port, but that's a bit sucky. So is there a different icon maybe or something like that? And is there some visualization that makes sense for having wires come in and out of the top and the bottom of the node? I don't know. Port labels is the other interesting one to think. But there we are. The basic principle is there. Need to spend some more time tidying it up. Can you connect out wires to the input port? So at the moment, if it's in return mode, there's nothing stopping you wiring it up, and that's something we need to prevent. But from a visualization point of view, though, you want to be able to read the flow, and the flow in our left to right parsing of how things move. The messages come in here and they sort of leak out the sides of the node out to wherever they call, and then they come back in the side door to then go out the main exit. And we don't have a good visualization for side doors. Now what's interesting is we have got things like the catch node, status node, complete node, all of which can be used to target other nodes. So there's a possibility of, if there is another sort of visualization of this virtual connection between nodes, that it might be something we could reuse with those nodes. I don't know. And the other bit I've conveniently ignored on our link call node is message.done. So this was the new async messaging API we introduced last year, which allows you to track messages through a flow, and that only works as long as the node's called done when they're finished processing a message. And semantically, we wouldn't want to call done on a message until, interestingly, semantically, do we call done on the message after we've passed it, or as we pass it to the target, or should we save calling done on that message until down here when the messages come back. Because if we wait till down here, that would actually allow you to do some interesting work around the node supporting timeouts. And if there was some way to be able to correlate the messages between these 2 points. I mean, message ID is there, but there are scenarios where the message ID can be changed. It's not a unique identifier, and messages can get cloned and all these sorts of things, which does make tracking messages through a flow a tricky prospect. But if we found a meaningful way to track the message from this point where it gets sent to the link node and here when it returns, then there could be timeout options, there could be error handling options, there could be other interesting options to help wrap the calls to the subroutines, which are really quite interesting. But that only works if we can correlate the call to return the message to this original message. And given we have no guarantees, given we're already reliant on _link source surviving, but that does survive if the message gets cloned. Message ID, and I said, there are scenarios where that can change. Like the split join nodes can really mess with the message ID. Need to think through that a bit more. In my mind, it makes sense semantically to call done when the message has been returned and we're about to pass it on in our flow, not the called flow. So we would need some way up here to stash done to one side so that when it pops back here, whether it is the message ID property, we try and retrieve done, then that might work. And I suppose if we put this in a weak hash set, although do we have weak hashes in Node.js these days? Then, we would risk leaking a memory leak by, if the message ID changed, then we wouldn't be able to correlate it and we'd just be building up this list of done callbacks that never get invoked. So anyway, these are the challenges to do this properly, but we've got the basics working and that's cool for an evening's work. Otherwise, we've got 2.1 beta towards the end of this week, beginning of next week. Things are coming along quite nicely. There's a new tab menu which lets you do things like hide all flows. Where have your flows gone? Where have the flows gone? Oh, that's interesting. I've just found a bug with hide all flows. Anyway, and then show all flows. Yay. Maybe I just want to hide this one. Or maybe I want to hide the other flows so I can just focus on this one. Things like that, with lots of options for hiding and showing. Anyway, that's a bit of fun. Show all flows. Cool. Well, thanks for joining me. Good progress on the link call node. We'll carry on with that. Well, I will carry on with that in the week because if we're going to do it properly, kind of want to get it into the beta. Otherwise I will be back same time, same place next Monday. If you're watching the videos, do like and subscribe. If you're watching on Twitch, do say hi. Just have a good week. Be merry, be fun, and it's a cup of tea time. Good night all. Bye.